Good morning. In today's class, we will be discussing about flame front propagation and the factors which are affecting the flame speed. So, for efficient combustion, in case of SI engine, the rate of propagation of flame front within the cylinder is quite important. There are two important factors which determine the rate of movement of flame front across the combustion chamber. The first one is the reaction rate, which is a purely chemical combination process in which the flame eats its way into the unburnt charge. So whatever flame will be developing, whatever burning charge is there, it will mix with unburnt particle and the flame will spread. Then there is a transposition rate. It is due to the movement, physical movement of flame front, which is relative to the cylinder wall, and also because of the result of pressure differential between the burning gases and unburned gases present in the combustion chamber. We can see a figure, a curve, showing the rate of flame propagation. In this, we can see there are three different areas, 1, 2, and 3. In first one, that is from A to B, the flame front is progressing relatively slow due to a low transposition rate and low turbulence. The transposition is very little since only a small mass of charge have been burned at the starting. The low reaction plays a dominant role, resulting in slow advance of flame. As the flame front leaves this zone and proceed into more turbulent areas, that is our second section, it consumes a greater mass of mixture and progresses more rapidly and at a constant rate from point B to C. The volume of unburnt charge is very much less towards the end of flame travel, and so the transposition rate again becomes negligible, thereby reducing the flame speed in our third zone relatively due to low turbulence. Now we can see the factors that are affecting our flame propagation. The study of factors which affect the velocity of flame propagation is important, since the flame velocity influences the rate of pressure rise in the cylinder, and it is related to certain type of abnormal combustion that may occur in case of SI engine. There are several factors which affect our flame propagation, like air-fuel ratio, compression ratio, engine load, turbulence, engine speed, engine size, and other miscellaneous factors. If we see about air-fuel ratio, the fuel-air ratio or air-fuel ratio has a very significant influence on the flame speed. The highest flame velocities, or we can say the minimum time for the combustion, are obtained at somewhat rich type of mixture, that is point number A. As shown, this figure is showing the effect of mixture strength on the rate of burning, as indicated by the time taken for complete burning in a given engine. When a mixture is made leaner or richer, we can see the flame speed is decreasing or the time taken for combustion is increasing. Less thermal energy is released in case of lean mixture, resulting in lower flame temperature, whereas a very rich mixture may lead to incomplete combustion, which again result in less amount of heat energy released. The second factor is our compression ratio. The higher compression ratio increases the pressure and temperature of mixture, which also reduces the initial preparation phase of combustion, and hence a less ignition advance is needed. High pressure and temperature of the compression of the compressed mixture also speed up the second phase of combustion. The increased compression ratio reduces the clearance volume and therefore increases the density of cylinder gases during burning. This increases the peak pressure and temperature, and the total combustion duration is reduced. Thus, engines having higher compression ratio have higher flame speed or lesser combustion timing. Then, engine output. The cycle pressure generally increases when the engine output is increased. With the in increased throttle opening, the cylinder gets filled to a higher density. This results in increased flame speed. When the output is decreased by throttling, the initial and final compression pressure decreases and the dilution of working fluid increases. The smooth development of self-propagating nucleus of flame become unsteady and difficult. The main disadvantages of SI engine are poor combustion at low load and necessity of mixture enrichment, which may cause wastage of fuel and discharge of unburnt hydrocarbon and products of incomplete combustion in the atmosphere. Next factor is our turbulence. The turbulence plays a very important role in the combustion of fuel, as the flame speed is directly proportional to the turbulence of mixture. This is because the turbulence increases the mixing and heat transfer rate between the burnt and unburnt mixture. The flame speed is quite low in case of non-turbulent mixture and increases with increase in turbulence. It is mainly due to additional physical intermixing of the burning and unburnt particles at the flame front, which expedites reaction by increasing the rate of contact. The turbulence in the incoming mixture can be generated during the admission of fuel-air mixture through comparatively narrow section of intake pipe, valve opening, etc. in the suction stroke. Generally, turbulence increases the heat flow to cylinder wall. It also accelerates the chemical reaction by intimate mixing of fuel and oxygen. It also helps in burning the lean mixture also. However, excessive amount of turbulence may extinguish the flame, resulting in rough and noisy operation of engine. A suitable design of the combustion chamber, which involves geometry of cylinder head and piston, may increase the turbulence to a desired amount during the compression stroke. Next is engine speed. The flame speed increases almost linearly with engine speed, since the increase in engine speed increases the amount of turbulence inside the cylinder. So the time required for the flame to traverse the combustion space would be halved if the engine speed is doubled. Then we have engine size. The size of engine does not have much effect on the rate of flame propagation, but in case of large engines, the time required for complete combustion is more, since the flame has to travel a longer distance. This requires increasing the crank angle duration during the combustion. This is one of the reasons why the large size engines are designed to operate at low speed. Some other factors that are increased flame speed are supercharging of engine, spark timing, or residual gases that are left in engine at the end of exhaust stroke. If we supercharge the engine, the intake pressure will be increased And during the compression stroke, we can achieve a high pressure and temperature. So it will speed up our, it will reduce our initial preparation phase and also speed up the combustion, speed up the second phase of combustion. The amount of residual gases present left if also affects the flame propagation. If a large amount is present there, then in case of exhaust stroke, the unburnt fuel particles may be there. So for this, what we do, we generally supply a slightly lean mixture in case of SI engine. So these were the factors which are affecting the flame propagation in case of SI engine. In further classes, we will be discussing about abnormal combustion and the factors which are causing abnormal combustion. Thank you.